Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
Hi, everyone. Hope you're having a good day wherever you are. My name is Sean Henry, and we're going to talk about agents and hacking and semantic kernel today. So first of all, I already introduced myself. My name is Sean Henry. I run the semantic kernel team here at Microsoft. And we'll talk a lot about using semantic kernel today, what it is, how you can use it to build agents. I'll stop at a couple spots for questions. So if you have any questions throughout this, please put them in the chat, and also leave some time at the end to take questions as well, and Anna may interrupt me as well, and if there's some questions that that folks would like to talk about while I'm going through stuff. I'll start off with a question. I saw a lot of people in the chat already are using semantic kernel and are familiar with it, but for those of you that aren't, I'll introduce it as our lightweight, open source, production ready orchestration middleware from Microsoft. So that's a bit of a mouthful, but what it really is we're a library to help you build agentic and AI applications on top of your favorite languages, either Python or .NET or Java. I'm going to be focusing in this session mainly on Python, but for those of you that use .NET and Java, we do have full support for those languages, and all the samples that I'm showing today on Python are also available in our .NET framework, agent framework as well. And you can find those on our GitHub repo, and I'll have lots of links to those as well. So what does this mean to be a lightweight, open source, production ready orchestration framework? Well, really, the thing we wanted to focus on with semantic kernel is we wanted to be ready for production enterprise developers. There's a lot of orchestration frameworks and libraries that you can use out there to build your AI applications. And with semantic kernel, we really wanted to focus on that robustness and that need for taking your applications to production. And what does that mean? Well, it means number one, we focus on being stable. We go through that typical software development process of having previews and release candidates and general availability. And at that point, we declare our APIs for example, version 1.0, and we don't break our APIs at that point. And in fact, many of the APIs I'm talking about today in this session are built on our agent framework, which just recently last week went to general availability. We've been working on it for about 6 or 7 months. And iterating on it, and we went through previews and release candidates, and we finally kind of locked it down, got it to a place where we liked it, and now we've declared that version 1.0, and so that's going to be a nice stable platform for folks to build their agent applications on, and not have to worry about the API changing every week as you update your libraries. The other one, of course, is important, is supportability. That's something we focus on as well. Not just through being supported through Microsoft support, but also through GitHub and the communities on Discord, where my team is there every day answering questions about semantic kernel and helping you build your semantic kernel applications. And the third one that we focused on is security. We wanted to have a library that that a Microsoft full-time employee was verifying all the code that went in, so you could do our software development lifecycle internal to Microsoft and verify that Everything is done in a secure way and meets Microsoft's Secure Foundation initiatives. Those are kind of the things that we really wanted to focus on, in addition to, of course, all the features that you need to build your AI applications. And so what are some of those features that you might need? So with Semantic Kernel, we're an orchestration layer. So we're about connecting all those AI services that you need in order to build your applications, your AI applications, and your agent applications. And this starts with kind of the core piece, which is, of course, being able to connect to AI services and models, your large language models. So with Semantic Kernel, we allow you to connect not just to the Azure and the Foundry models through Azure OpenAI and through the Foundry catalog, but also through models that are not hosted in Azure, like OpenAI directly, all the models available on Hugging Face. We recently announced support for NVIDIA NIMs, which allows you to use models optimized for NVIDIA cards, both in the cloud and locally. We can also support things like DeepSeek, and even Google Gemini and AWS Bedrock models, and Anthropic through AWS through connectors that we have. So you connect your application to those models, and then all your code stays the same as you use it through Semantic Kernel. So you can kind of build your application once, and you can kind of pick your model and your capabilities that you're using with it. In the same way that we connect to all sorts of different AI services, we also connect to local models. So we have adapters on top of Llama. We have adapters on top of LM Studio. We have adapters on top of Onyx, which is our native runtime for Microsoft for running these models. And this allows you to run local models like the Llama class models. But an interesting one that's recently been released is the new 5.4 multimodal and mini models, which are great for building agents because they now support function calling. So you can now have full agent experiences that are run 100% locally, are run free. You can develop them locally on your machine. Then you can deploy them to the cloud, or you can continue to run them locally. So those are kind of the AI services, the LLM models. We also support connectivity to memory services. So if you're doing things like retrieval augmented generation, if you're doing search, you want to connect your agent to a vector store. Again, we support not just Azure AI Search, but also connectors to all the popular third-party vector stores like Elasticsearch, MongoDB, Quadrant, and others. In the same way that we've been connecting to large language models in the cloud and also to memory services in the cloud, we're also now starting in preview with Semantic Kernel to connect to other agent hosting services. So first and foremost is Microsoft's Azure AI Agent Service that's part of Foundry. And I think you'll be hearing a lot about that today. I think there's a bunch of sessions on that, and that is a great way to build and deploy your agents quickly and easily into the cloud. And you can build them through the Foundry AI Studio. You can build your agents there, and then you connect to them through Semantic Kernel, and you can orchestrate multi-agent systems together through Semantic Kernel there. In the same way that we do that with Foundry agents in the Azure AI Agent Service, you can also connect to Bedrock agents, you can connect to Crew AI, and you connect to AutoGen, which is Microsoft's research framework for building multi-agent systems. So you can take your agents that you may have built already in something like AutoGen, and you connect them in through Semantic Kernel. So those are the services that we connect to from third parties. You also want to be able to connect it to your own services and your own capabilities. So we support that through a plugin model in Semantic Kernel. This gives you connectivity to APIs and services you may have built natively. So I'll show you how you do that in code. You can just annotate your code, and you can have your LLM then call directly into it. You can have endpoints that are open API endpoints. So other services you may have enabled and create an open API spec for. MCP is very popular now. This is Model Context Protocol. This is a format for bringing in tools that LLMs can use. It's very popular if you're using things like Visual Studio Code or Cursor or other IDEs that support local code execution. And then also all the Microsoft capabilities through things like Logic Apps. You can also declaratively define your agents and prompts in Semantic Kernel. We have our own format for prompts through YAML and our Semantic Kernel format. We've now recently merged that. If you've used PromptD before, which is a Microsoft format for defining prompts, we've now merged that into our agent framework. So that's something you can use as well. And then finally, as you deploy your application, one of the most important things is being able to observe your agents. So Semantic Kernel emits open telemetry throughout the whole library. So you can connect that to things like Azure Monitor or Aspire, especially folks who are in the .NET space. Aspire is a particularly good choice, as well as things like Azure AI Content Safety through Prompt Shield. So this allows you, the whole package allowing you to build your production-ready AI applications. It's a library that helps you build that more quickly, a stable platform that you can build on top of, and then build your applications and then deploy them anywhere. You can deploy them to Azure, you can deploy them to AWS, you can deploy them locally, whatever you like. So we're an open source framework, and really our goal is to connect all these services.
Sean,
Yes.
we do have a question in the chat. They're wondering, does Semantic Kernel have anything in their development pipeline to support MCP?
Oh, spoiler alert. Yeah, we'll get to that. We'll get to that. I got a good demo for that in a second.
Perfect.
MKG, yeah. Yeah, we'll
Thank
get
you.
to that. I'm just scanning through some of the other questions. Yeah, looks like this is great crowd. I will keep going here. So let's talk about agents. This is what you're here to build, is agents. You've probably all seen this slide. I bet you everyone from Microsoft is showing a slide similar to this. What is an agent? So when we think of an agent, it's something that can reason over a provided business model, can reason over some task, can get context to complete that task, complete the process, and can perform an action for the end user. So I like to think of concretely, like, what does this mean? What does this actually mean when you're building your application, when you're coding your application? So in Semantic Kernel, we think of these as models. You're reasoning over a business process. That's done by your large language model that you use. You use GPT-4o, or you use any of the models that are available to reason over some particular process. That's the brain of your agent. You retrieve context for that process. So that's a memory. That's the memory of your agent. That might be either something you stuff in the prompt, if it's just a small amount of context, or you might have a knowledge base that the agent accesses through something like a vector store. It does a semantic search or any other kind of search to retrieve that information. It might be a regular database search, and then brings that information into the context so that it can reason over it. And lastly, which I think is the most important thing, which really differentiates agents from assistants and kind of traditional large language model usage, is that the agent can perform that action. And it does that through something called tools, and we call them plugins in Semantic Kernel. Some people, some models call them skills. Some models call them tools. All the same thing. And what this is the ability for the large language model to be given a set of tools it can use to perform an action, and then choose which of those tools it wants to use. And this is kind of really the innovation that unlocks the ability to build agents. And this is what we have extensive support for in Semantic Kernel. Okay, so Semantic Kernel has been around for a couple of years, and we've had this concept of models and context and memory and plugins. I showed that on the last slide, all the things we're doing with those. And when you combine all those together, that's where you have an agent. So we've been doing agents in Semantic Kernel for, since the beginning, since Semantic Kernel was originally created, since before agents were cool, I guess you could say. But we now have an agent framework that builds on top of these, that takes these concepts and ties them together in a single API that you can use in order to build these agents that have models connected to them, have context and memory and plugins connected to them. Then you can interact with them like agents and use these to build your applications, whether they're line of business applications or BizOps applications, or building new APIs or new agents to unlock new value for your task that you want, that you have at hand. I'll show you a quick demo. By the way, all these demos are up on GitHub in aka.ms/sk/hacks. You can take a look at all of those there. But I will switch right over and show you building a basic agent with Semantic Kernel. Again, all of these demos are in Python that I'm going to go through. We're going to focus on Python here, but they're also all available in C#.net. If you go to our GitHub repo, you can find them there as well. So I'll just quickly go through some of the prerequisites and needs for building an application with Semantic Kernel and Python. Obviously, having Python installed for local development. All these samples will use Azure OpenAI. You can use regular OpenAI. You can use a different model, and I'll show you how to do that. And then, of course, you have to install the SDK. Within Python, very easy to install the SDK. I'm running everything here in a code space, which means I don't really worry about virtual environments or anything. But to install it, you can just use pip install, one package to install Semantic Kernel. There's a few different ways you can set your keys. You need to go get your keys from the OpenAI service. I like to do those with a .m file. Here's an example of one of those files here where I've set a few of the keys. These aren't real keys. Don't try them. I'm not going to show you my real keys. But you'll need all these keys from, either from Azure, the AI Foundry Studio here, or if you're using OpenAI, you can get them from OpenAI directly. That's what that looks like. And then all the samples on the repo you can run directly in Python. But I'm going to walk through one of the first ones here. So this is all it takes: 17 lines of code to write an agent with semantic kernel. So we'll look at the first relevant part here. I'm creating my agent. In this case, I'm creating a chat completion agent. I'll talk about some of the different types of agents there are later, but chat completion is the most common one. This is the one where you connect your own model, your own service, your own tools. And the most simple of an agent connects to a service. In this case, I'm connecting to the Azure chat completion service. I could give it, you can see here, I could give it my API keys directly, but semantic kernel will pull those from your .env file if you have that set up. So here, I'm not actually passing any parameters. We'll pull that locally from the .env file. I give it a name, and I give it some instructions. Here are just very basic instructions. And then to actually call your agent, you take your agent and you get a response. In this case, you ask for a response to the message. In this case, I'm asking it to write a haiku about semantic kernel. So we'll see that run here when it comes up. So you can see down here that it has given us a response. Code weaves meanings thread, semantic kernel ignites, AI knows the way. Oh, it's very inspiring. So that's the most very basic symbol of agent. You may be saying, well, that's no different than what I can do when I talk to a large language model directly. And it's, in some ways it is. So the next thing we want to do is we want to add a plugin to our agent. This is the tools I was talking about. How do you have an agent actually do something useful? So in this sample here, exactly the same as the sample we showed before, except a couple things that we've added. Number one is down here on this plugin line, we've given it a plugin called menu plugin, and I'll show you that in a second. And then we've given it some arguments. In this case, these arguments are telling it to give our response format in a menu item format. So let's look at what those things are. So first of all, the menu plugin is a set of functions we've defined that, in this case, an example, simulate getting information about a menu at a restaurant. So we have two functions in this case, one that gets the list of specials. And in this case, just returns a string. You would probably have it, in reality, talk to your database here at this point, or be able to pull that data in. So it's returning the soup special, the salad special, and the drink special. And then another function for getting the price of a particular item. And then you can see here we've added some annotations to this. Again, for the C# folks, we use the annotations from C#, but very similar mechanism to what we do in Python. So we have this kernel function annotation. We say it has a description. This function provides a list of specials from the menu, and it returns the specials from the menu. So we say we give it the data about what the function does and what it returns. And for our get item price, we say this provides the price of a requested menu item. Given the name of the menu item, it returns the price of the menu item. So what's going to happen when we call the LLM is it's going to take all this metadata, it's going to bundle it up, and it's going to give it to the large language model, and the large language model is going to decide which tools it's going to use. And then instead of returning a text-based answer, we're going to ask it to return a menu item-based answer, which is a structure that has a price and a name. So instead of saying, the salad special is Cobb salad and it costs $9.99, it's going to return an object that has a string for the name and the float. So I'm going to put a breakpoint here, and we'll actually see exactly how this works. So if I'll run it here, and so what's going to happen again, exactly the same as what we had before in terms of building the agent, giving it a name, giving it some instructions, but we've now added these two extra pieces to it. So when this runs, what's going to happen is it's going to call into our breakpoint. You see what happened is behind the scenes, when we called this get response for this message, semantic kernel took this message and it added the instructions for the agents. What we gave to the large language model, basically in text, is we said, you are a helpful assistant. You have the following tools to answer any questions. And we say you have a tool called get specials that provides a list of specials for the menu and returns specials from the menu. You have another tool called get item price, which provides the price of a requested menu item. And given a menu, and takes the parameters of the name of the menu item and returns the price of the menu item. And always return your answers in the form of a menu item with the format price and name. So we give it all that. We take that, we auto-generate that and put that into the prompt that we give the LLM. And then we say, user message, what is the price of the soup special? So that's all the text that the LLM gets. And then it looks at that and says, oh, okay, to get the price of the soup special, I need to call into these functions. So in this case, it's calling in. So I guess it already called the special one. It didn't have the breakpoint in the right spot, but it's now getting the menu item. It's now getting the menu item for we should be able to see here the menu item, and then it's returning $9.99 for the price. And oh, wait, here we go. Actually, that was because I had this breakpoint wrong. We will put this back to here. There we go. That was wrong. We haven't called it yet. So we're going to call it here. And now it's going up to the LLM, and now it's asking for the price of the menu item. And it's returning that the soup special is $9.99. And we can ask it a compound thing. So we can ask it maybe two things that needs to call into both these functions. We could say, what is the soup special? What is the soup special and its price? So in this case, the LLM is going to need to make two calls. It's going to need to make one call to get the soup special and then one call to get its price. And so we'll actually do both of these in one turn of the call to the large language model. So we see this run. Okay, now it's all set up, and we're going to ask for the response. What is the soup special and its price? And so now we'll see it call both of these functions. So now it's asking for the specials from the menu, and we're going to return what the three specials are. That goes back to the LLM, and then it calls back and it says, what is the price of the clam chowder? So it took the information from the first call and then gave it to the second call to ask for the price. And then now it's going to return down here that the price is $9.99 and the name is clam chowder. So that's now in this format. So I showed two things that are very powerful. Kind of the two most powerful concepts in semantic kernel are being able to annotate your existing code and have it be used by an LLM, and then to return structured data in the format that you can now give back to your existing code. So semantic kernel is really about connecting your AI code to your existing code for your application. Okay, so all that was done in the terminal. What if we want to see this in UI? So I just want to quickly show you guys a nice, easy way to build a UI with semantic kernel. I really like using a tool called Chainlit. Chainlit provides integration with semantic kernel. If you go to their website and you look up integrations with semantic kernel and Chainlit, you can see how to use this. It's very easy. We build integration to semantic kernel and integration to Chainlit to make it work really well. You can just copy paste this code, and it will get you started building an application with Chainlit. And I'll show you what that looks like here. I'm just going to run this application here. I'm passing this W parameter, which means it will automatically reload. That's not actually necessarily important in this case. But what this will give you is a nice UI for actually chatting to your agents. And so here you can see I've created this UI with Chainlit, and then I can ask it. So this agent here is a weather agent. So it's got a function. We talked about functions where it gets the weather. And so we can ask it, it only does some cities. So we ask it, what is the weather in Paris? And you can see we get this information of what the tool call is. So we can actually see in our UI with the integration with semantic kernel and Chainlit, we can see that we provided the input of city Paris, and then the output, the weather in Paris is 20 degrees C. So we can actually kind of debug what tools it's using directly from the UI. And then, of course, it's maintaining the context of this chat. So I can now ask it, how about London? So I haven't actually asked it about the weather, but it knows from the context that I'm asking about the weather, and it's able to call the tool directly. And again, now it's asking for London, and we get the weather for London. Now, again, in real life, you would connect this to a weather service and use it that way instead of having sample data. Okay, so those are some quick demos of how to use Semantic Kernel. I'm just going to check if there's any questions in the chat. It's pretty good so far. Some questions I'll get to at the end around, I see ADK in here. I'll talk about that at the end. Okay, let's go back to slides. Okay, we did that. We don't need my backup slide, which is great. Okay, so what we showed there is we went from actually, you know what? I'm going to do one more demo. Let's do this demo first. I think this will be better. Let's show, we want to see MCP. Someone's asking about MCP. Let's do an MCP demo because that's basically the same. I showed you tools inline. You can also connect to tools through OpenAI, or you connect to tools through MCP. So for those of you that don't know what MCP is, it's a fairly new protocol, I think from like November, December of this year that Anthropic developed. In particular, it's useful or was developed for use for local tools. So used either with these kind of computer use assistants or with IDEs like Visual Studio Code or Cursor, where you can have them actually operate on files on your local file system. But it's now being used a lot more even for remote services, and there's a lot of traction. You can go online, you can go to the MCP website, the Model Context Protocol.io website, and you can find all sorts of connectors that you can use. In fact, let's do that real quick. We can see, if we go here, we can see, if we go to their GitHub, you can see on there a lot of servers for, if we go to servers right here, here's a bunch of servers that they support. So they have a kind of a catalog of servers. You can see these are kind of the reference servers, which are well supported. You can see things like being able to do search through Brave, Git, I'll show you that one, being able to generic things like being able to fetch content from the web, Google Maps, Slack, SQLite if you want to have a database connection, as well as a ton from third parties that have been added as well, and a bunch from Microsoft in here you'll see. So you can connect these directly into your LLM. Instead of writing code for these, you can use these tools that have already been created and are specially designed for LLMs to interact with. So this is a great catalog as you're hacking, as you're building your applications. Don't try and write this code yourself. See if there's an MCP server available for you to use and integrate with that. And I'll show you how that works in Semantic Kernel. So we're going to use the GitHub plugin. So in this case, we're using the MCP Studio plugin, the MCP Studio plugin from the connectors that we have in Semantic Kernel. So we've built this STDIO plugin for connecting directly to MCP. This is based on, and we're taking a reference on the official MCP SDK, and the same thing on the .NET side. We're using the Microsoft.NET MCP server under the covers. And so when you connect to an MCP server, you give it these parameters, a name and description, but the important piece is you give it the commands and arguments that are needed. And you can find these if you're over here and you click on one of these. So for example, we're doing Git. You can find the information here on how all the tools it has, but then also the parameters that you need to use it. So this is how you use it with a Docker container, and this is how you use it with UV. So in this case, we're using the MPX version. And so what actually happens with these Model Context Protocol servers is it actually uses MPX. If you guys don't know what MPX is, this is the package manager for Node.js. You can also have it use YUV for Python. It's a Python plugin, and it actually then pulls that code down and is executing in this server locally that then knows how to talk to GitHub. So it's actually pulling the code down and using it in the local directory. So we're giving it the command it needs to do that. We're saying use MPX and find under Model Context Protocol, find the GitHub server. So we've done that, and we've created this GitHub plugin. Now we're just going to create our agent, just as we did before. We're creating an agent that can search the Semantic Kernel GitHub project, and we're giving it this MCP plugin as a plugin. So now it's a tool that our LLM can use to answer questions about GitHub. So this sample, we're going to ask it 3 questions. We're going to ask it, what are the latest 5 issues in the Semantic Kernel repo? Are there any untriaged issues? And what's the status of this particular issue? So we have those three things. We're going to run this. We're going to run this sample here. And again, we're just running our agent exactly as we did before. We've connected this tool, and then we're running in a loop for each of these three user inputs that we gave it. And what it's going to do is it's going to pull down all that information from the GitHub plugin, and it's going to call GitHub, and it's going to answer these questions. So what we'll see here, it's now running. And the first question we asked was, what are the latest 5 issues in the semantic kernel repo? And it's now returned those 5 issues. Look, we got someone there. You guys are talking about MCP. A to A is kind of the latest thing that was announced earlier this week. We have someone working on that integration with the agent. That's an agent-to-agent protocol. A bunch of stuff we're working on internally. Are there any untriaged issues? Yes, there are 26. Oh, so we got to do some work triaging our Python issues. I guess we didn't get to that this morning, so we got to do our triage, and we can look at this particular status of an issue. So particularly with the GitHub plugin, you can give it your personal access token from GitHub, and now you can have it actually create projects, check in things for you. And this is how things, if you've looked at agent mode from GitHub Copilot, that's how it works. It uses these plugins to be able to actually suggest changes and make changes to your code, create new repos, pull down repos, do all that kind of stuff. And of course, you can also execute, you can do things on files locally, and you can connect to all these different servers. So that's MCP. You know, once you create your MCP plugin, you use it just like you would any other plugin in semantic kernel, and it works just like that. There's also some samples in our repo of if you want to use semantic kernel as an MCP server, which is also interesting. If you want to build a semantic kernel application and then have something like Visual Studio Code or Cursor be able to actually talk to it and then have it do an action on your behalf. So that's another interesting thing you can do with MCP and semantic kernel. Okay, let me get back to my slides. So we looked at a bunch of agents here. We looked at the very basic agent, an agent that has no tools and is really just a prompt. We still call this an agent, and the reason why we like to still use an agent framework here is because later on, as you grow your application, it makes it much easier to add things like tools down the road, to add things like telemetry, observability, if you start by using an agent framework, even if you have a very simple example. And we show was really kind of the core of the single agent, which is an agent that's scoped to a particular task. This is an example here of a RAG agent, so an agent that's doing search. The user here asks a question. The agent generates a query. Might be to a semantic search, a vector database for a semantic search, might be a regular database, generates some responses, takes those responses and generates a human readable response for those using the LLM. So that's the concept of like a single agent. That's a very common example. But what we're kind of here to talk about is multi-agent systems. And this is where now when you have more advanced problems and you want to have agents that you can chain together, that can collaborate together to solve more complex problems. So this is a case here, this example, or maybe you're trying to use a multi-agent system to build a marketing campaign. So you start with an agent that specializes in talking to the user. And this might be an agent that maybe uses audio instead of text to talk to the user. So this is your user proxy agent. It then talks to your coordinator agent, which builds the plan for this marketing campaign. And then the coordinator agent uses all these specialized agents to solve different parts of the problem. It might do a web search. It might do a search on a local knowledge base, on a local database, or it might execute some code. The coding one is really interesting. You may have noticed that large language models are not very good at math, but they're very good at writing code to do math. So anytime you have a problem that needs some math, it's actually much better to write the code to solve that math problem and then have it execute in a container. This is something you can do with a multi-agent system. You also see here that there's different models being used. You can use in your coordinator agent, you might use one of the more advanced reasoning models to build out your plan. Then you might use some models that are cheaper and more tuned for tasks like searching the web or talking to a database. Or you might use a small language model that's maybe running locally and very specialized in things like coding. So with a multi-agent system, you have all these options of how you want to break apart and build your system. So why would you want to do this? So what we see when you build multi-agent systems, if you start with, this is some data from Agentic One, which is a pattern that the AutoGen team developed for solving general problems. with a multi-agent system. And when they kind of solved this particular benchmark, which is the Web Arena benchmark, when they went after this with a single agent system, a simple model-based agent, which is what I showed you, a model that doesn't have any tools, that is just talking to the agent that is just talking to the model directly, it didn't perform very well. And when they used that kind of technique in the middle, where you had an agent that had tools and capabilities, it worked a little bit better. The agent was actually able to do things, but they got a big jump when they started moving up to these multi-agent systems. And particularly when you use these multi-agent systems that have the ability to get feedback from a human. So the human can assist it as it's solving the task. And of course, you get very close to pure human levels of success on these benchmarks. And so you're saying, well, why is it not as good as a human? Well, yeah, it's not quite there. And what are the advantages of multi-agents with a human in the loop is that you can scale much more. You can move much more quickly. And so you don't have a human spending 100% of their time on a particular task. You have the multi-agent system doing most of the task, and the human is helping it along or improving it at particular steps. So you really get that scale and that speed by combining a multi-agent system with a human in the loop. The other thing that you get with a multi-agent system is you get better performance. So this is some data from two benchmarks here. One using a single agent GPT-3.5 agent, and performed 48% and 32% on this particular task. And then the blue bar is performing the same task with GPT-4 with a single agent. And you can see there's a much larger improvement. But in the middle, you can see a GPT-3.5 multi-agent solution performs almost as well as a GPT-4 solution. And then, of course, a multi-agent system performs even better and basically breaks the test at this point. So what does that mean? Well, it means with a multi-agent system, you have options. You can either, you can use potentially a less expensive model and get the same performance as you would with a high performance model. And actually, this is what you see a lot with these reasoning models, is they're actually emulating multi-agent systems, within the service. And so you can use a non-reasoning model in a multi-agent system and get kind of reasoning levels of performance. Or you can tune your performance using a less expensive model when you potentially don't need as much performance as the high performing model. Or you can use the best model in a multi-agent system and get even better performance than is possible with a single LLM or with a single model. I just went way too far forward. Spoilers. Okay, let's look at multi-agent systems with semantic kernel. So we'll start with a pretty simple multi-agent system. Let me go back over here to my code. Okay, multi-agent systems. So one of the most common ways to build multi-agent systems is what I showed you there, where you have a single coordinator agent that then talks to other agents within the system. So in this sample here, we're building 3 agents. We have a top-level agent. This is kind of the user proxy agent, that agent that talks to the user. We're calling it the triage agent here. And then it has 2 other agents that it uses. It has a refund agent and a billing agent. So this is like a billing system for an organization that's going to help the user kind of reconcile their bill. And so we have one agent that specializes in refunds, and we have one agent that specializes in billing. And then we have a triage agent that decides which of these agents to use. And in the same way that I showed you how to use tools, this is how you build multi-agent systems. You just pass those agents in as tools. So in semantic kernel, you can pass in plugins that I showed you earlier into your plugins, but you can also pass in agents as plugins, agents as tools. You can connect those directly. So now this triage agent, it will perform its task, but we have forward requests about charges, billing cycles, payments, fees, blah, 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 to the billing agent. Forward requests about refunds to the refund agent. So it's going to use those other agents to perform its task. It's going to have those agents help it because those agents are specialists in those particular tasks. So in this case, these are fairly simple prompts, but you can imagine, like what I was showing you in those previous examples, you might have agents that specialize in accessing a particular type of data, agents that specialize in coding. Keeping your agents as small and focused as possible can deliver much better performance. So let's run the sample and we'll see what happens. So I'm just going to grab here this from the example. Okay, so what we'll see is we'll end up into an interactive chat here when this starts running. and we're going to ask it a question, and we're going to say, I was charged twice for my subscription last month. Can I get those payments refunded? And what you'll see is it's now calling both the billing agent and the refunding agent, because I asked it both about refunds and billing, and so it's asking each of those agents to help. And now it asked them, and it got a response. So the refund agent now gives this response. And then the refund agent gives this response, and the billing agent here, oh, that's not quite formatted. Yeah, it's hard to see. This is the billing agent giving its response here. So the triage agent asked both the agents for a response, and they both gave a response. And now the triage agent is going to take both those responses, and it's going to synthesize them into a single response. So we had the refund agent here give its response. We had the billing agent here give its response. Now the triage agent is responding to the user with its response, and it says, it seems you may be dealing with a billing issue. Here's how we can proceed. How to handle the duplicate charge, that came from the billing agent. How to handle the refund request, that came from the refund agent. So you can imagine now building these trees and these complex nodes of agents, using semantic kernel. I want to show you another multi-agent system, or a case where you may want to use multi-agents. And this is, I talked about earlier, using semantic kernel with agents from different systems. So in this case, one of the things, if you've attended any of the sessions earlier, or maybe even later around the Azure AI agent service, it offers a bunch of built-in capabilities for your agents. It offers Bing search grounding, so it can search the web. It offers file search, vector search. It offers code execution. These are things that are already built into those agents. So we're going to build a multi-agent system where we have one agent that is talking to the user, and it leverages another agent that is hosted in the Azure AI agent service to perform some of those tasks. Let's take a look at what this looks like here. So we have two agents we're creating. We're creating a search agent, which is an Azure AI agent. So this is an agent that's hosted in Foundry. So this is an Azure AI agent class that you can use. And I've had you have to do some definition work to pull it in and get the credentials for it. I'll show you that in a second. And then we have a second agent that is our chat completion agent that helps the user. And just to distinguish the two, I'm asking it to talk like a pirate. And so now what we're going to do, we're going to ask it, which team won the 2025 March Madness. This is something that none of the models would know on their own. They were all trained, months ago. But we're going to have it actually search the web for, a recent piece of news. So let's have this run. But while this is, my code space is restarting. I think I hit F5 too many times. While it's happening, this is a great opportunity for me to show you exactly what's going on here with agents in Foundry. So again, a lot of sessions on this, but you can actually build your agents directly in Azure Foundry. And so here I have a couple agents I've created. I've created a weather agent, and I've created a Foundry agent. I can create these agents here. I can give it instructions. So this one it answers questions about searching the web. My weather agent does a bunch of stuff around the weather. I can try it. It's a playground here that I can use to talk to my agent. So this is another chat interface you can use to talk to your agent directly. But I'll show you, if I go back here, what the most important thing is with this is I can connect it to grounding with Bing. So you can see down here, I've given it some knowledge. We can take a look at this here. If I go into here, we can see that I've given it a connection to Bing grounding search. So now it's going to be able to use Bing to search the web. So going back to our code here, hopefully I didn't lose any of my logins or anything. We have our first agent that I'm going to talk to, and it's going to now, and I've given it as a tool, like we talked about earlier, a plugin. I've given it the search agent. So the first agent, my agent, is going to use the search agent to actually do the search on its behalf. Let's see what happens when we actually run that. And so, while this is starting, I'm going to ask it a question. I'm asking a question about March Madness, which is something that just happened a couple days ago. I've asked it that question. It's now going to use this search agent as a tool. And that search agent is then going to go up to, it's hosted in the cloud, it's hosted in Foundry, so it's not hosted locally. Oh, it didn't show, okay, it did not show the answer from there. But what we can see actually, okay, so this is actually great. We can show, we asked the question and then it responded with as a pirate and said the Florida Gators won March Madness against the Houston Cougars. Great, talking like a pirate. Did it actually talk to our search agent? Well, let's go check. So if we go up to Foundry here and we click on our search agent, and we can see our threads. And we can see here a thread. Right now I'm on the West Coast, 12:44. We can look at this thread and we can see that it was asked the question, who won the 2025 March Madness? And it replied, not like a pirate. That was the first agent, the user proxy agent, that talked like a pirate. The search agent talked like a normal agent. And it gave us the response from searching the web, and it gave us some sources. So the sources aren't showing up here, but you can pull those out from the SDK. If you can reconcile these sources, and you'll actually get like you'll actually get like a website that you can then go and use as a reference. And if you want to download the data from that website, you could then take the URL. You could use one of those MCP servers that I showed you earlier that will actually download that data. They'll convert it into a format like Markdown that agents like to use, plain text instead of all the HTML, and then you can pass that back into your agent. So I see a question about that here. So that's how you do that. Okay, I'm going to keep rolling along. What's next? I will show you group chat real quick. So group chat is a technique where you have agents help each other with a solution. So in this case, we have two agents. We have an art director agent and a copywriter agent. So this is a copywriter agent will generate slogans, and the art director is a critic. So we have this author-critic pattern where the critic is giving feedback to the author agent. So we take those. We have this copywriter that writes copy, writes humorous slogans, and we have an art director that gives it a critique on those slogans. So this is a small example. You can imagine this like if you're writing a large report, you may want to have an agent that generates sections in that report, and then have another agent that gives it a critique on those sections and generate a better response. And so we can see here when this runs, we put it inside a group chat here. So we create this group chat with Semantic Kernel. We give it the two agents we created, the writer agent and the reviewer agent, and we give it a termination strategy. So our termination strategy is, first of all, only go for 10 iterations. So that means it doesn't go forever. And then also use the approval termination strategy from the agent reviewer. So if we look for this approver strategy up here, it says if the art director says the word approved, then we can stop. And so we can see here when we're running, we start with the copywriter gives an option, says shockingly smooth, electrically yours. The art director gives it some feedback. The copy director says drive the future, fully charged. It tries and then the art director gives it more critique. And actually, I see a bug here in my code. So what happened in this case? This is the interesting thing with LLMs. You got to be a little bit careful with the response. So we just did a simple check here to say if the word approved was in the history. And guess what? The art director says not approved. So our code didn't work. And so there's actually another sample that falls on this on a repo that actually does an even better thing, where instead of looking for the word approved, we actually send this text up to an LLM and say, does the art director approve, true or false? So when you add that extra step, you wouldn't kind of fall into this trap that we did here with this simplified example, where the art director said not approved, but we assumed that was approved, and then we exited and said, we now have the right response. So that's an interesting live code. You guys see some things. But so what you should do when you actually build this, instead of just looking for the text string, actually send the response up to an LLM and ask it if it's an approval or not, and then it wouldn't get trapped by this not approved. Or the other thing you can do is you could ask the art director. I showed you structured data before. You could have the art director respond in structured data where it has one part of the struct where it gives the feedback, and another where it explicitly says approved equals true or false. That's another way you can do it in this case. Okay. Those are multi-agent systems and multi-agent techniques in Semantic Kernel. One thing I want to show you guys quickly before we go, a couple quick board demos. So I showed agent service, using agents from agent service. I showed Semantic Kernel, that's our production-ready library. We also have AutoGen at Semantic Kernel, which is our AutoGen at Microsoft, which is our research library. And so the AutoGen folks built a really nice technique called Magentic 1, which I talked about a little bit earlier. And what it does is it's a technique for multi-agent systems where you have that planner and coordinator agent, and it has a set of other agents that it can use specifically for solving a task. So there's a file surfer agent that can read files. There's a web surfer agent that can access the web. There's a coder agent. There's a computer terminal agent. And so all these agents can be used together, like a team of agents working together to solve generalized tasks. And kind of the innovation that it has on top of these special agents is it has this thing called a task ledger. So it builds this plan, and then it tries to get these agents to execute the plan, and then it detects if the plan is successful or not, and will actually look to see if progress is being made, and if it's not, it'll try a different plan. So it's kind of self-healing in that way. So I'll show you a sample of that. We have a sample of that on the Semantic Kernel repo. And actually what I want to show you, I'm going to show you here a recording I did the other day with actually the C# version. We do have a Python version as well. But I want to show you the C# version because something interesting happened when I ran it. Again, normally I only go for one error in my demos. This will be the second one, but this one's on purpose. So this one actually doesn't count. So I'm running this demo here, and there's this coordinator agent that is going to build the plan, and it's going to talk to this agent team that has all these other agents that it's using to solve the task. So when I run it here, it's going to bring up a semantic kernel application. It's going to create this Magentic 1 team, and then I'm going to give it a task. So in this case, I'm giving it a complicated task: calculate the distribution of the top 20 largest cities in the USA. And so now it's building a plan for that task. It's deciding which agents it's going to use for it, and it's now asking each of those agents to solve the task. So the first thing it's going to do is it's going to generate the plan, and now it's going to ask, I think the first thing is the web surfer agent. It's going to ask the web surfer agent to go look on the web to figure out, so search and retrieve the latest authoritative distribution of the top 20 largest cities. So it does that. It found a website. It got the information. It's now going to execute in the code agent. It's going to execute find the distribution of those agents, and so it's going to execute some code to find that distribution for the different cities from the category. And now it's going to visualize it. So the last thing it's going to do is it's going to ask an agent to generate a chart for it, to generate an image for it. And this is when I was running this demo where I screwed up. I didn't actually configure the visualizer agent properly, and so it didn't have the ability to actually generate the image. So you can see here the Illustrator agent didn't work. It says I'm experiencing technical difficulties. And so what we'll see is the coordinator agent is going to keep trying. It's going to try in a few different ways. It's going to say try harder. Try and generate this image, and it's not going to work because I didn't configure the Illustrator agent correctly. But what happens next after it tries 3 times is really interesting. So we'll see here. It's going to try, I think, one more time. So it's a video, so it's not gonna stall. Yeah, okay. So now it didn't work. It tried 3 times, and now it went back to the coordinator agent. It evaluated the status, and it generated a chart in ASCII because it wasn't being successful generating an image. So it now generated a text-based chart with the distribution. So that's kind of a neat way where these systems can be self-healing and solve problems on their own. So that's Magentic 1. That came from AutoGen. But this demo here is running that Magentic 1 sample on top of Semantic Kernel. Okay, so last but not least, let's talk about kind of more complicated agent systems. So now with all these pieces, we can pull them together. This is how you would build something like a deep research multi-agent process. You've seen things from things like there's a deep research in Bing Copilot now. There's a deep research that OpenAI developed. There's a deep research that Google developed. This is how those things work. They're multi-agent systems. So they go off and you ask it to research a particular topic, maybe like how to build agents. It goes back and forth. There's a user proxy agent that generates an outline for you, searches the web for some basic searches to figure out, what is the report you want to generate. And then once it figures that out, gets confirmation from the user. By the way, we're using kind of our best models at the beginning to try and generate that best outline possible. We can then fan out into these different section writers, and we can run those in parallel. And within those, we can have these sub-processes that are doing things like that writer, agent, author, critic pattern, where they're iterating and refining and building each section talking to it's querying the web, trying to find information about each section for this research project, this research paper that it's trying to write. And then finally have an editor agent at the end that consolidates everything and then generates a report, and then maybe uses something like MCP to write it to the file system, write some markdown file or a PDF or something to the file system. That's how you can bring all these things together to build a multi-agent system. I do have one final demo I want to show you that is somewhat agent related, but I really like it, and actually hopefully it'll work because I had that reset earlier. I will just do this real quick. Let's see if that's working. Okay. So one of the things that we've done in Semantic Kernel, I mentioned those user agent proxies don't necessarily have to be text-based. We can also make them real-time audio-based. So we have real-time audio capabilities in Semantic Kernel, which allow you to talk directly to your agents and to your Semantic Kernel applications instead of talking to them through text. I'm just going to make sure this is running here. Okay, looks good. And what we've done on top of that is you can actually use things like Azure Communication Services, which lets you actually connect via things like SMS or calling. So what I have here is we have this sample application that actually connects. You can see our Semantic Kernel functions here for the weather, and we actually connect it to real-time audio. So we handle the real-time audio data. And then further down here, we actually connect it to Azure Communication Services, which gives us the ability to actually phone our agent. So what I'm going to do here, I actually have my phone here, and I'm going to connect it to my speakerphone. And what we should see, if you guys can hear this.
Hello, how can I assist you today?
Yeah, can you tell me what the weather is in London?
The weather in London.
Actually, can you tell me what the weather is in Seattle?
The weather in Seattle is currently hot. Would you like to know anything else?
No, that's it. Thank you. Bye. So a couple things there, really interesting. A, I was talking to you on the phone. That's magical. 2, I was able to interrupt it halfway through. So these new real-time models, you can actually have a real conversation. You don't have to wait. You don't have that lag. It happens very quickly in real time. And then I was able to talk directly without any changes to my agent code in Semantic Kernel. So that was a nice little demo showing, how we can actually talk to our agents in real time. Okay. Great way to cap it off. A couple other things. So our journey, we talked about single agents. We talked about multi-agents. We talked about complex business processes being built using Semantic Kernel. More things to try. Here's some examples here. You can connect to other agent services like Bedrock Agents, Crew AI, AutoGen. You can connect to Copilot Studio with Semantic Kernel. You can have Copilot Studio connect to Semantic Kernel by using a skill. Copilot Studio is our low-code framework for building agents at Microsoft. You can use Azure AI agents. I showed you that in an example. You can have that execute code, do file search the web. You can use local models. I didn't show you an example here, but all these examples that I showed you, we could use local models with a Llama or any other connector to run your models locally. And then, of course, I know for hacking, you're probably not going to do this, but you really need to add logging and telemetry at some point. So we have extensive logging and telemetry support in Semantic Kernel. So that's another thing you can try. Okay, finish things off. Our GitHub repo, go to GitHub Semantic Kernel. Definitely check it out there. We have over 150 samples for Python, 150 for .NET. We have all sorts of samples up there that you can go and learn how to use agents. We have a Learn site, tons of documentation there. And of course, please join us every Wednesday. We have office hours. If you have any questions about Semantic Kernel, the entire team is there. We're answering questions and we're showing demos of the latest stuff that is available from Semantic Kernel. Great, that is it. I have a little bit of time for some questions if there's any. Anna, if you've been paying attention, or Pamela, any particular questions that I can go over?
We have had a couple questions. Pamela has been doing a great job in the chat answering them. Let's see what we have here. Just scrolling. Sorry, bear with me, everybody.
I see one that just came up. RAG with Semantic Kernel. Yes, of course. We have I didn't talk about it too much here, but we have extensive support for connecting to memory services. So I talked about that a little bit at the beginning in that first slide. But yeah, you can have Azure AI Search, you can use that as your vector store for RAG. You can use things like Elasticsearch, and we use a lot for local search. You can use some of the other models, some of the other vector stores available there as well.
Got another question from Sam here. Do these agents talk to each other? Also, what if you need the agents to run in a certain order of operation? How do we orchestrate that?
Yeah, great question on order of operation. One of the things I didn't cover here on top of this is we have something called the process framework. So if you want them to run in a particular order, we have a graph-based approach as well that you can use. We're still working on that. That's in preview, and most of it's been done on the C# side, but we do have some capabilities in Python, and those will be coming over to Python very soon. But certainly if you're a C# developer, that's all ready to go on that side, and I'll be coming to Python soon. And that's a graph-based approach, similar to if you've used something like LangGraph. That's an approach for building agent flows that way, and that gives you a lot more control. If you don't want the agents to kind of come up with their own plan, you can use a graph-based approach to give them a deterministic execution order.
Awesome. And I think we can wrap with this nice little piece of housekeeping question. What time are the office hours on Wednesday?
Oh, great question. So every week they are at 8 a.m. Pacific. So that's 11 a.m. Eastern. And then also once a month we have APEC office hours, which are late in the day Pacific. I think it's at 7 or 8. If you click on this, you'll see links to when the office hours are. And so if you're elsewhere, if you're not kind of in North America or Europe, you can do those once a month office hours as well. Great. Thank you very much. Thank you for joining me. Please reach out to the team if you have any questions. I'm really excited to see what you guys can build with Semantic Kernel. I think it's a really great way to quickly build agentic applications.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.